This is the Mathematics Education Podcast from mathedpodcast.com. Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and today I have two guests with me. Sean Yee is an assistant professor at the University of South Carolina with a joint appointment in the Department of Instruction and Teacher Education and the Department of Mathematics. Sean, thanks for being here.
Thank you.
And I also have with us Jonathan Bostic, who's an assistant professor in the School of Teaching and Learning at Bowling Green State University. Jonathan, thanks also to you for being here.
My pleasure.
So Sean and Jonathan have co-authored an article that was published very recently in the Journal of Mathematical Behavior, Volume 36, and that's entitled, Developing a Contextualization of Students' Mathematical Problem Solving. So we're going to be talking to both of them about that article, but as always, I like to start by just getting on the map where people are from in terms of your graduate studies. So Sean, first of all, where'd you do your graduate work and what was the focus of your dissertation?
Thanks, Sam. I did my work at Kent State University in Ohio, and my dissertation was on conceptual metaphor theory, so metaphors that students use to discuss problem solving, so very closely related to this article, in fact. I focused on what conceptual metaphors, and those are the concepts did they bring to the table that they talked about, so essentially what experiences did they try to communicate for problem solving, and this was mainly focusing on geometry students at the secondary level, 9 through 12.
Okay, and who advised your work there?
Ann Reynolds, super lucky. What a wonderful, wonderful person. She just recently retired too, but what a great program they have there, and I just can't speak enough to her and the quality of advisors. I've been fortunate enough to have that lineage of good advisors.
Yeah, it's wonderful. And Jonathan, where'd you go to graduate school, and what was the focus of your dissertation?
So I did my doctoral work at the University of Florida in Gainesville, Florida. My advisor was Dr. Stephen Pape, and co-advisor was Dr. Tim Jacoby. And like Sean, I can't say enough good things about both of them. They were fantastic in getting me through the process and being supportive, thoughtful, and passionate about the work that I was doing. Mm-hmm. My dissertation study explored sixth grade students' problem-solving performance as well as their unit test outcomes after experiencing an instructional approach called teaching through problem-solving, or teaching via problem-solving, which comes from Schroeder and Lester in 1989, so it's been around. And then I gathered data about how they solved their problems, that is, what representations they employed in a pre-post fashion. And then I also compared their outcomes and experiences to business as usual mathematics teaching with a comparison teacher. A related part of my dissertation study involved creating a measure that addressed sixth grade students' problem-solving ability while also addressing our relevant state-level mathematics standards at the time. So my work came out just prior to Common Core, and now that's leveraged me to thinking about improving it for Common Core standards.
Mm-hmm. So clearly you're both, working independently on your dissertation studies that involve problem solving at different levels, and the article that we're talking about in JMB involves problem solving with middle school students and high school students. But how did you guys link up with each other? What brought you together to be doing this work on students thinking about their problem solving?
So it's kind of funny. We met at PMENA, Psychology and Math Education, North America, in Columbus, Ohio. I think that was 2010. We were both grad students, but John was a year ahead of me. In other words, he was finishing up a little before me. And honestly, we met each other when he came in the front door, but then we sat down together for lunch, and we got to talking, and next thing you know, he said, oh, really, we're both in problem solving. What's interesting is that we were in different fields of problem solving. He was middle school, I was high school. He was doing more with representation theory. I was dealing more with linguistics and metaphors and discourse. And so despite those differences, we had this common thread of problem solving. That was really nice. And so we decided to persevere and talk more, and then over the next couple of years we saw each other at conferences, and we said, hey, we've got this data, let's come together and see if maybe we could look at it from different perspectives.
We shared that how I had data from my dissertation study looking at sixth grade students' problem solving. I had their unit tests, I had problem-solving tests, but I also had Think Aloud data where I'd interviewed them pre-post, those in my intervention group receiving the intervention, as well as a group that was in a comparison group. And Sean said, hey, I've got pilot study work as well. And we kept the conversation going and thinking about, was there a mutual interest? And I think that's how we came together, is having many open conversations about what interested us and what data we had and what we could add to the field.
Mm-hmm. And so there has been a lot of work for a lot of years on problem solving in general, but you guys take a little bit different perspective. You're looking at students' contextualization of problem solving. So I was wondering if you could just help us understand what you mean by contextualization of problem solving and how that relates to the other kind of more standard studies of just problem solving itself.
Sure. We'll start by saying that contextualization isn't necessarily clear in the Common Core State Standards, and when you think of it in context, saying that word tongue-in-cheek, it's used in a variety of ways. And so we started to delve into the literature and think about how is contextualization framed, how have others thought about it, and also drawing on what do we believe at our cores. And so we started to ask ourselves, what context did students bring to problem solving? We weren't necessarily looking at how do students contextualize problems, but we wanted to think about how do they contextualize problem solving itself, the process, the experience of engaging in problem solving. So our framework stems from much of Nielsen and Reeve and von Glasersfeld. So our contextualization provides a framework to characterize how students perceive problem solving. And we did this by thinking through the lenses of situational, which is what I did, looking at students' representations, and their cultural contextualizations, which is what Sean did with the conceptual metaphor theory, as a means to understand their conceptual contextualization. So we feel that our ideas about students' contextualization of problem solving is really coming from students. It's not something that we've necessarily imposed upon them. It's what are they saying to us in their work, as well as in their words while they were engaging in this problem-solving experience.
Yeah, I think it's very important to realize that one of the things that when you talk about how problem-solving has been studied in the past is that we've seen a lot of studies. This is a very classic design from the 70s and 80s and 90s when cognitive science started to take hold, that when people were studying problem-solving, say, well, what is it? And they would go out and they'd take some students in and they'd observe some students, and then they would go back and read some books and think of theory and try to come up with something on their own, essentially. In other words, they would collect a little data, and then most of the development came from them sitting in a room and reading books and researching and thinking about proper models. Well, the nice thing here is that we were able to use the students and make the students' voice be heard through the whole story because we were able to triangulate from so many different angles, from the cultural, from the situational. We were able to look at it, to use those multiple angles to really let the students' voice come through so that the contextualization of problem solving is not our words, but theirs.
Mm-hmm. Giving the students a voice like that, it becomes important to hear a little bit about who the students were. So could you just tell us who your participating students were, and then what data did you collect from them?
So we had 6th grade students and 10th grade students. The 10th grade students were from my pilot study, and the 6th grade students were part of John's experimental and treatment group. The data we collected from these students is we had video data, as well as the hard manipulatives and artifacts. So the artifacts that the students wrote on, or when they used the manipulatives, we had that on video, and we were able to send the data back and forth between the two of us. Being at different universities, it was a little tricky, but we got the video data back and forth, and we were able to look at each other's work, and we gave each other's data a full analysis as we would in our own techniques, basically, and then we brought the conversation together, and we looked at them more holistically because of that. John looked at it looking at, again, the situational contextualization, which was representation theory, and I looked at it through the language and what language they used. So John looked at the artifacts and also the language, but focusing on how they were able to come to conclusions using the situational information, and I looked at it at what language they used to communicate that information. What words did they use? How did they try to communicate that to the interviewer?
There's one small detail in the analysis, specifically in the representation piece that we added after looking at the data once and thinking about where we were going. And in many studies, the artifacts that are examined are students' work products, specifically what they write down. And we found that to analyze the representations coherently and consistently across participants, that we needed to go back and watch the videotapes over and over and over again to see when did they reach out to use a concrete manipulative, when did they switch, at what point. And we did that after realizing that when we were analyzing our data, we were missing something, and so we needed to be able to tell the student's story best by describing when they changed representations, when they translated, and when they transformed what they were doing with their work. So I did want to plug that there's a little nuance in our representation work.
Mm-hmm. Thank you, John, for adding that. Yes, that was very true. Yeah, and that was needed.
My guests are Sean Yee and Jonathan Bostic, who have recently published an article in the Journal of Mathematical Behavior entitled Developing a Contextualization of Students' Mathematical Problem Solving. So then you talked about these kind of two different levels of analysis that you brought to, give a deeper interpretation to the students' contextualization of the problem solving. So in terms of your findings, let me first ask about the students' talk. How did the students talk about problem solving, and what metaphors did they bring as they were making sense or talking about it?
To get into that, like I said, when we were watching the videos and we had to go back and forth, this was a challenging part on how to analyze the data. And so the framework, make sure you read the paper to get a full understanding of this, but the theoretical framework really comes into play here. So speaking to the grad students who are listening, make sure at this point in your work that your analysis really locks in with respect to your theoretical framework. Like Jonathan had just alluded to, we talked about coherence and consistency as significant variables with respect to measuring and discussing how we could see whether the metaphors agreed or disagreed. We needed the appropriate qualitative and quantitative methods, as our paper shows. So with respect to the metaphors, we listened for the language they used, and the language that the sixth graders were using was more of is, am, are, was, were, and have, has, had verbs. Every once in a while they throw in an equals. The high school used students, the 10th graders, used more of they would stop and try to give more conversations such as, from here I'm lost, okay, or I don't know where to go from here, or now I see what I'm trying to find, or my mind's eye is not seeing it right. They would put in these metaphors and language that would show an association of a certain context, right? So this is what we're talking about when we say contextualizing problem solving. On a separate note, this doesn't have as much to do with this paper, but they did see problem solving as a journey, searching, visualization, building which closely related to constructivism there. So there's a lot of important data here, but that's that's a separate paper that's in the process. What we found with this study is that a common theme that kept coming out consistently was they kept saying find out, or figure out, or came out, or pulled out, or got out of this problem. And so it was interesting, this word out. Jonathan and I really looked into this. What do we mean by the word out? What are we talking about with this out? Why are the students keep using this? Why do they keep using this word? And so we went back and we analyzed the data over and over from both of our perspectives, and a lot of good things came out of that. This would be actually a good chance for Jonathan to share what he did then with it.
When I looked at the representations, or I should say we looked at the representations, 3 impressions came out. And again, I'd encourage people to look at the paper to have a deeper understanding. But three impressions came out. One was that high school students employed more diverse approaches than the middle school students in our sample. Middle school students typically employed symbolic approaches, yet they did this successfully only 2 out of 9 times. There really was a difference in the number and the type of representations that middle and high school students were using when we compared those with similar performance levels. The second impression that we drew out was that facility with non-symbolic representations was connected to problem-solving performance. And there was consistency across the middle school and the high school students in seeing this, as well as comparing those at similar performance levels, so an above average to above average performer. What I mean by that is that we called students above average performers, comparing them to a larger group that we sampled them from.
Okay.
So non-symbolic representations, for example, were employed 7 times in our study. 4 of those were successful, whereas in total, symbolic representations were employed 11 times, but successfully only twice. So putting this another way, those who employed a non-symbolic representation were more than 3 times more likely to reach a solution than their peers using a symbolic representation. And then we had a third impression, and it was very nuanced. We tell the story about Betty. Betty engaged in this problem-solving manner. She sought to reason about the task in a coherent manner, which, while she was working with non-symbolic approaches, this was in stark contrast to many who used symbolic approaches. What we notice is that those who typically use the symbolic approaches tend to do it without making sense of the problem situation. So their problem-solving manners were fairly incoherent and or they were inconsistent with the problem.
Yeah, that was the big thing.
We had three impressions from our representation work that complemented Sean's conceptual metaphor theory analysis. Sean, is there anything else to add there?
Well, yeah, so the thing, when you say compliment, John, you got to remember we've already figured this out. So we should say, right here we actually were struggling for a little bit because we said, well, gosh, what can we do to understand the symbolic and non-symbolic representations and this word out? How does this all relate?
That's right.
And so one of the things in conceptual metaphor theory, and this is all thanks to George Lakoff back in the 80s, I want to give a shout out to him and his wonderful work, he's over at Berkeley, was that the idea of an ontological metaphor is the idea that you're going to be changing your reality or your perception of the situation. And when you think of this idea of out, we listened very closely and we were able to come up with a framework to build off of that was very different and also very helpful because students were saying the word out to get to the solution. And in is not inside the inside material was the given. And what we found was the problem was actually the container. So they see this as the container, and the inside material is the given, and the outside is the solution. And how do they get there? How do they get from the inside to the outside was used to the help of the idea of approaching or getting through the container was all because of the representations.
Well, I think this goes to if someone wanted to know what is a key takeaway from the study, what is something that we drew out, and what Sean is hinting at is that the representations that students were using while engaged in problem solving, not necessarily the procedures that they were applying to those procedures, the representations were the means to figure out a solution or get out of the container and get to this space outside of the container where the solution exists. So we felt that was a very key, compelling piece coming from students' language and their problem-solving work, is that they see all of the information bound in this container. That is the problem's text, its ideas. Their thinking, their contextualization is, how do I get out of that container? And so we learn from taking our two results, our two sets, and drawing on the bricolage metaphor of putting pieces together to build something that we feel is coherent, and that was that those who can meaningfully employ more than one representation while problem solving are more likely to be successful. Also important is that that students recognize, well, if I have facility with different representations, I can try different representations to help me get out of this container, to leave the container and get to the solution space. And we learn from listening to what students did and the representations they were using, how they recognize limitations with a representation. They also recognize limitations that they had with it. There was one instance where a student tried to use a pictorial approach, and he stopped himself and said, well, I'm not sure this is where I'm going. And I paraphrase. So he stepped back and went back to his previous representation because he felt more confident with it. He felt like there was something appropriate about it. And it did work. He eventually pushed harder on the container and got out. So we were able to synthesize across the 2 points.
And the container metaphor is actually, you yourselves have a visual representation that you've used of the container metaphor, and is that the one that people can actually find through the publisher's website?
Yeah, if you just Google JMB or in the Elsevier website, you just look us up in the contextualization of problem solving, you'll get the abstract of the paper, and we have a pictorial abstract so you can see how this container comes into play, how the language and the representations work together to really make it clear that it's not so much that they used a symbolic representation or a non-symbolic, but did they have enough representations that would give them a better chance and a better understanding of how to move through the problem.
And it gave me kind of a new image in my own mind of the students that were working symbolically but not successfully reaching a solution in their problem-solving process. I now kind of have this vision of them, inside the container using symbols and pushing these symbols around, but not really in a meaningful way. And so it means, okay, they're pushing the ideas around inside the container, but they're not figuring it out, or they're not actually breaking through to the solution, which is kind of, outside.
Yes, you're absolutely right, Sam. And I think something the listeners would appreciate is that graphical abstract that you can find that Sean referenced, that took a lot of time and effort over the course of 12 to 16 months to develop that container metaphor and get feedback from others, especially when we submitted preliminary versions or earlier versions to places like PMENA when we first presented it. And from there, we drew upon feedback from our peers and thought about it more deeply. And that's how we were able to get the container metaphor into Journal for Mathematical Behavior, was really thinking about it and taking that feedback.
Yeah, if I could just say two more things, too. So I think the model, thank you very much, Jonathan, for mentioning how long it took us to come up with that. This type of stuff takes time, and the value, as you said, Sam, about how you can now see them working with it. You have an image, at least, to describe problem solving. You have a contextualization of problem solving. That's very useful for another reason we talked about when we reflected at the end of the paper about, well, we all heard the kids talking about getting out, figuring out, but what's figuring in? What's going the other direction? What was really nice was that was a very good, insightful angle to look at reflection. So the idea of going from the solution to the problem, changing the problem, realizing what you've done, that was very, very helpful. So I would suggest that's something that was really nice about the image as well. And one other thing, as Jonathan said, this took time, and the collaboration, we talked about how we had just, from the beginning of this interview, we just met, and we, how did we know to continue on and keep pushing through? Because there were times where we were like, oh gosh, what are we doing? But the nice thing is that, and I would suggest this for the grad students too, that if you've got a main line of research that lines up, these conferences are so helpful because you get to collaborate and find out other angles that people are thinking. And Jonathan and I were very different, but we were able to find a common thread in terms of what we mainly wanted to do. So even the smallest door can open to the biggest room. It's an important thing to remember when you're looking for collaboration.
Absolutely.
I'm speaking with Sean Yee and Jonathan Bostic about their article, Developing a Contextualization of Students' Mathematical Problem Solving. It's been fun talking about the article. I also have another fun question to ask both of you, and I'll start with Sean again. So Sean, if you weren't in mathematics education and finding all these productive collaborations in the field, what do you think you'd see yourself doing instead?
I originally was thinking of being a sous chef and going into cooking, to be a chef.
Oh.
The problem is that to be a master chef, you have to go through the sous chef system, and man, does that take a long time. 15 to 30 years of your life just to get there sometimes. And I said, I'm not willing to be working that long. So my plan is said was to become a professor, become rich, right, of course, and then be able to have enough money to start my own restaurant when I'm retired. We'll see if that's still feasible in the future.
Is there a particular type of cuisine that you're most, have an affinity for?
Yeah, actually, I'm multiracial, so I was looking for synergy between Italian and stir-fry. And I think that idea actually took hold in a couple of cities where you've got the pasta base and then you've got a stir-fry on top. So I've seen a little of my thoughts coming through, actually.
And Jonathan, what about you for the same question?
So I'm an avid fisherman. I love to fish, both fresh and saltwater. I have most of my life. And when I was an undergraduate in college, I went one summer to the Outer Banks, like I did many summers, and I went on a boat offshore fishing. And the captain was impressed enough with me that he offered me a job as a deckhand to come back during the winter break when the tuna run by the Outer Banks and work on his boat. And I seriously considered it. Because I liked fishing and I enjoyed it. I knew the work, and it's very hard work, but it's it's also something that was just very rewarding to me. And so I would eventually like to have that kind of life where I'm able to go fishing and also take others fishing, because I really take joy in seeing others enjoy it and have fun and experience the thrill, and also be engaging in sustainable aquaculture, I think, is very important. So even as a fisherman, I recognize, to be careful with our oceans, our lakes and waters. So I'd be a fisherman, honestly.
Sean, how are you at cooking fish?
Yeah, exactly, right. John and I need to go fishing sometime, and I'll need to cook it up. Exactly, yeah, that'll be good.
Absolutely. There you go.
Well, thank you both very much for coming together to talk about your work.
Great, thank you very much, Sam. Really appreciate it.
It's been great. Thank you so much, Sam. I appreciate this opportunity.
Thank you for listening to this episode of the Math Ed Podcast. If you'd like to support the podcast financially, please use the PayPal donation button at mathedpodcast.com.